Okay, guys, I'm back. And we left off here. I asked you to finish these on your own. So hopefully we all got the same answer. So remember, we're talking about multiplying by the complex conjugate. And when I do that, you should have gotten 1 times 1 is 1. Then I'm going to get negative I plus I, and then minus I squared. I have like terms here I can combine, so that's going to cancel. And I'm just left with 1 minus I squared. And we talked about the fact that I squared is equal to negative 1. So this is going to give me 1 minus negative 1, which is 1 plus 1. And that gives me 2. So by multiplying by the complex conjugate, I end up with just a real number. The imaginary part goes away. So that's the whole point, because sometimes when we're dealing with complex numbers, we want the imaginary part to go away in certain instances, which we'll get to on the next slide. All right, so again here, I'm going to multiply by 4 plus 3i, because I want to use the inverse sign of my imaginary part. That's going to give me 16 plus 12i minus 12i minus 9i squared. Again, these cancel, which is going to give me 16, and my negative 9i squared becomes positive 9, so I get 25. And then the last, I'm going to multiply by negative 3i, which gives me negative 9i squared, which is equal to positive 9. So I hope you're good with that. Moving on to the next slide. So we're going to use complex conjugates to divide complex numbers. You can divide them. However, we want our final answer to be in the form a plus bi, right? So that means I can't have this in the denominator, this 4 minus 2i. I can't have that in the denominator, because then it's not in this form, this a plus bi form. So I basically want the imaginary part to disappear in the denominator, because then I can write it in this a plus bi form. So what I'm going to do is I'm going to erase this, and I'm going to, I didn't mean to do that. Okay, so I'm going to multiply top and bottom by the complex conjugate of the denominator, and we're going to watch something happen here. And I can multiply any fraction by something as long as the top and bottom are the same, because that's equivalent to 1, so it's not changing anything, right? So when I multiply my numerators, I'm going to get 8 plus 4i plus 12i plus 6i squared in the numerator. And in the bottom, I'm going to get 16. Remember, my middle terms will cancel, so I'm not going to write those. And then I get negative 4i squared. So when I check, I simplify, combine like terms, my numerator is going to be 8 plus 16i plus 6i squared over 16 plus 4, right? And then remember, this I squared here is actually negative 1, so that's going to give me 8 plus 16i minus 6 over 20, and then 8 minus 6 is 2 plus 16i over 20. So you see now in the denominator, I have no more I. So I can now rewrite this so that it does look like a plus bi. So that's the same as 2 over 20 plus 16 over 20i, where this is my a and this is my bi, right? So I'm just going to erase that for a second, because I don't want to put the circles there. But this takes a long time to erase. It's kind of annoying, actually. I wonder if I could, oh yeah, let me use a bigger eraser. Okay, so let's go back here. So my answer is 2 over 20 plus 16 over 20i. And you can simplify that to 1 over 10 plus 4/5 I. Okay? And then clearly this is in the form a plus bi. So using the same logic for b, I'm going to multiply top and bottom by negative 2i, the complex conjugate of the denominator, because that's going to give me negative 6i over negative 4i squared, which can be simplified then to negative 6i over positive 4, which is just negative 3 over 2i. And in this situation, I don't have a real part, I just have an imaginary part. So my a is actually 0, and my b is negative 3 over 2. Okay, moving on to the next slide. So now we're solving quadratics that have complex solutions. So we can solve this one of two ways, right? X squared plus 4, we can solve it like we would solve an equation by subtracting positive 4 to the other side. And then I have to take the square root, so I'm going to get plus or minus the square root of negative 4. And now that we know that I is equal to square root of negative 1, I can actually answer this. So x is equal to plus or minus 2i. Or I could factor it. So how could I factor x squared plus 4? Well, that is going to be, let's see, do I want to get into this right now? You know what, let's pause. I don't want to do that right now. We're going to stick with just this solution for now. But we'll get into factoring in a minute. So I hope everybody understands how I did this. And that my solutions are x equals plus or minus 2i. Let's move on to the last slide. So this is a quadratic that's a little bit more involved, and this is not factorable, so I would have to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a, right? So in this situation, my a is 3, b is negative 2, c is 5. I'm going to substitute all those things in. So it's going to give me negative times negative 2 is positive 2, plus or minus the square root of b squared, which is 4, minus 4 times 3 times 5, all over 2 times 3. Then I have 2 plus or minus the square root of 4 minus, it's 60 over 6. And then that's going to simplify to 2 plus or minus square root of negative 56 over 6. Now you see I have a negative under the square root, which implies I'm going to have complex solutions because I have to use I. And we can simplify square root of negative 56. Let's see. 4 goes in. Let me just see 1 second here. Just using my calculator. So we can simplify that into 2 plus or minus the square root of negative 1, the square root of 4, and the square root of 14 over 6, which then becomes 2 plus or minus 2i radical 14. And those are my two solutions, my two complex solutions, because I have an I in there. Okay, so these are my solutions here. You could simplify this too. 2 over 6, and 2 over 6 would be 1/3. So I'm going to have 1 plus or minus I radical 14 over 3. So this is actually your simplified answer, which is what you should do. You should always simplify, right? And if you have any questions on this video, well, let me see. Do I have another slide here? I think I do. Oh no, I don't. That was the last one. Okay. So if you have any videos, sorry. If you have any questions, please post them on Google Classroom and I'll answer them as quickly and as best I can. Thanks, guys.